All right, so let's take a look at this together. This is our moon phase lab that we have. And so what we're going to do is we're going to create our moon phases using a chart and looking at the perspective angles that we see of our moon. So let's start out, first off, just by listing the different phases. So in the beginning, we've got new moon. Then we have what's called a waxing crescent. We've got, it's called a half moon a lot of times, but we're going to use the term first quarter. And I'll show you why in a minute. And then from a first quarter, we're going to go to a waxing gibbous. Then we get into what's called a full moon. You've probably heard of that before. Then we change to what's called waning. And again, it's a gibbous because it's almost full. Then we get into what's called a fourth quarter, which is actually another half moon. And then we get into our last, which is a waning crescent. All right, let's see how we get into this whole idea. Well, what it is this. When we line these things up, this is our angle between the sun, the earth, and the moon. So here's the diagram right here. And if I go from the earth to place number 1, this is called a new moon, right here. Always the moon has a dark side and a light side. The half of the moon that faces the sun is light. The half of the moon that faces away is dark. So I'm going to take a ping pong ball to represent that right there. There it is. Half of it's light from the sun, half of it's dark. That's what it looks like from space. But if we were to take a spaceship and land on Earth, it would look like this. And you can see there's no really any light except for where some of the paint's coming off. But it's all dark. This is during the day. The sun is back here, so I have sunshine here. I've got my moon in between. And during the day, in a new moon phase, we see nothing. We just see the dark side of the moon. So our view of the moon from Earth at a new moon phase is just a moon that looks like this. Nothing. It's just shaded dark. That's all we see. And if we were to draw an example of this, then I would say here's the sun. When the moon is between the sun and the earth, like this, we get to see from Earth that right there. And how long does it stay in this spot? Well, I got a little song for you, which is moon phases are awesome. Moon phases last 3.6875 days. 3.6875 days. There you go. 3.6875 days. Now we're going to go to the next phase, and this one we give a name called the waxing crescent. 45-degree angle. So when we look, a 90-degree angle is square. Half of that, half of 90 is 45. So this right here is a 45-degree angle. So right here is a 45-degree angle. From the sun to the earth to the moon gives us a 45-degree angle. Again, the moon, right down the center, has a line because the front half of the moon is lit by the sun. The back half is dark. So I put my same thing on there, ping pong ball. Then I change this around, and I say if I was to be in a spaceship and I was to land on the Earth, what would I see? Well, that's what I would see right there. Actually, it doesn't look very good because that paint splash there is not really great, is it? Let's put that more towards the bottom. There we go. Looks a little bit better. So there we are. We start seeing what's called a waxing crescent. There's the crescent moon that we start to see. The right side, all of a sudden the lit side of the moon starts to show up due to that 45-degree angle, And from space, we would say, oh no, I didn't change too much. It's just front side is lit, back side is dark. But our perspective from Earth gives us a view that looks like this. So we have shading on the left, and we've got a crescent shape for the moon. We call that a crescent shape. Kind of looks like a croissant. So it looks like that. This is when the moon has changed. Earth here, and the moon is now right down here. Still light in the front, dark in the back. This lasts for 3.6875 days. As a Lego movie reference. Then we go to the next one. This time, we're going to be at a little bit different angle. The Earth and the moon are side by side. So it's moved just here. And now we're side by side. And so when we look at this thing, it creates an angle straight down, making a box, which is what we call a 90-degree angle right there. So we're at a 90-degree angle. Again, front side of the moon is lit, back side of the moon is dark. So I take this baby, I move it on over, stick my tape on there, pop it down right there. Front side is lit by the sun, back side is dark. And then I say, if I was to land on Earth, on a space shuttle, that's what I would see right there. Right side light now used to be a crescent moon. The light side is starting to show up more due to a change in the angle. Back side is dark. So all right. From space it looked like that. But from our perspective, from Earth, it looks different. From space it looks like that. From our perspective, the terminating line, we call it, that's the line between the light and the dark, starts to show up. And we see that right there. Half moon, or what we call our first quarter. We call it a first quarter because if you look, this entire section right here is 1/4 of the circle. This whole section would be half. This would be that. So we call this a first quarter through the first cycle. So we're 1/4 the way through. Now we're showing number 4. And again, the moon, as the side lit by the sun, take my moon, I stick it back on here again, right over the drawing. So I stick it right here. Press it down. Side lit in that shadow. The angle right here is 135 degrees, right there, 135 degrees. So we're pretty open on this. But from this perspective, what does that look like right there? What does it look like? Holy cow! Just a sliver of the dark side of the moon is seen, but we see almost all the lit side of the moon. Not quite full, almost at the angle. So we're gaining view of the lit side of the moon and go down, gaining more view from the perspective. So again, I just say, I drew my sun, and now Earth is here, and the moon is moving slightly behind the Earth, and we're starting to see it like this. And that's 3.675 days. Each moon phase lasts for 3.675 days. Okay, Mr. Jensen, I think I understand this. And the way that we draw this is that terminator line starts to have just a little bit of curvature. It look like that, and that whack can get us. Then we get to a full moon. And a full moon, it's directly behind, right behind us. Just like that. If I put my piece of tape on there, I have my moon. And sure enough, from Earth, if we're going to land straight down, it's full moon like that. Full moon. As the rules say, straight on, there's really no angle. Even if it says 100 degrees, it just means it's a straight line. 180 degrees is just an opening right there. And this right here, it's drawn as the Earth and the moon, shin back, 3.6875 days in a full moon phase. Now we'll start to see a little bit different again, because now we're going to keep moving around the Earth, We're going to end up in this section. Now we're going to start actually change angles again. Going to go down to 135 degrees again. That's where we were here. 135 degrees. Again, front side of the moon lit by the sun. Back side is shadow. So I put my peak tape down. Stick my moon up there. Front side is lit by the sun. Back side in the shadow. Well, look, I turn it, I lay it on Earth, and there's just a slight shadow on the right hand side. Just barely the dark side of the moon starting to appear, but mostly the full moon. You see just a little angle of the dark side of the moon. So in this drawing here, I got my sun, I got my Earth, and now up here in the corner, it's moving in position around the Earth just a little more. And I start to see just a slight bit of the black side of the dark side of the moon here, and the light side starts to leave. Now I start seeing that angle. We go another half moon, so we go straight 90-degree angle here, and 90 degrees, we're just right on the side, right here. Oh, don't forget, in this section right here, front side is always lit, back side is dark. There it is. Stick our wonderful ping-pong moon on there. And we just have to go straight down. There it is right there. It's the half moon. Half of the dark side, half of the light side. So we draw that. Shadows on the right this time, not on the left, so different. Because it's going around, we're seeing a different side angle. That. Now we're starting to grow more light, more of the dark side of the moon on the right. Before I was to show you what it looked like, then Earth would be here, moon straight above like that. There it is. 3 seconds. And then last but not least, we've gone all the way around. Straight up from the Earth. We take this one, we draw our moon center, and again shade it. Let's put our ping pong ball there. That down. Turn this thing so that we look at it from Earth's perspective, and that's what we see. What we call waning now. Waning meaning it's taking a little bit just a little bit of the side is left. And pretty soon, we're gonna keep moving through 6 days to here, and from Earth, we're gonna go back to that original perspective to human. And it's all. So our waning concept that one, this one is almost fully taken over, almost come to a new moon. We shade all that side up there, shade all that side here. 4 or 5 degree angle. Earth is here. Moon's here. 3, 6, 8, 7, 5 days. Now we're into all of our moon phases from start to finish. On light to a full waning off the light.